Okay, so this is my game, Hopper Hero, and the objective of the game is to like climb the tree to like rescue your wife from like the crow who has like kidnapped your wife. So you can see this is the starting screen. There's a start button, and I have like another three other scenes. So level one, level two, which is basically the levels of the game, and then there's also the end screen. So uh, in my build settings, I've set it in order so that if I want to change scenes, it will be easier because I can just use scene manager dot load scene, and then I put in the build index of the scene I want to change to. Yeah. So pressing start. So this is like my game. I'll just pause it here. So as you can see, my game, the assets, I'm using the Pixel Adventure assets. Let me see, which is this is found in the Unity store and it's free. I'm also using the inside assets. I think this was found online. I can't remember the website now, but it's also free. Yeah. So yeah. So I'm over here. I'm using the maggot. I'm using the maggot asset, and I'm also using the maggot sprite, and I'm also using the beetle sprite. The beetle, you don't see it here, but it will come in the next level when I add a new enemy type into the level. I also use this fly sprite sheet, which was made by a friend of mine. So she helped me make this quick little fly flapping animation. Yeah. So in my game, as you can see, so for the animations of the game, right, such as the player, um, so the animation of the game, so over here, I changed the animations by setting up this state parameter, which has an integer value. So the integer value has like a corresponding movement state that is like assigned to it. So like player idle is actually like 0, and I think player run is like 1, for example. Yeah, the player run is like run. It's like 1, and then yeah. So I actually I have a I have a player animation controller. So in this player animation controller, I use a enum. I use enum to uh define the different movement states for my player. So over here, I define the different movement states for my player, and this makes it like more easier to follow and understand, and it's also like more efficient for me to just change the for me to just change the state in here, and then getting the integer so that I can change it in the animator state, in the animator the parameter. So here, um here I have an update animation method, uh which is responsible for just determining the appropriate animation that should be happening. So over here I take in like a few so in my parameter I have my direction, which is like the player's input the direction. So if it's like right, it'll be 1, and if it's left, it'll be like -1. And then is grounded is basically just a ground check, so it checks if the player is on the floor. Is charging is checks if the player is holding the spacebar. Since in my game you have to hold the spacebar to charge up your jump. And then vertical velocity. So if the vertical velocity is increasing, if the vertical velocity is increasing or like more than 0, it means that the player is like jumping in the sky and it's like increasing in height. But if the vertical velocity is like less than 0, it means that it's like falling down. So here I have a few checks. So the first check will be just to check if the player is like running left and right. So it checks for the direction. If the direction is positive, it means that he's facing the right. And if the direction is negative, it means that he's facing the left. So if there is no directional input at all, then the player is in the idle state, or that means the player isn't moving at all, so it should be in the idle state. So if the vertical velocity is more than 0.1, the state should be set to the jump state, so he will be in like a jumping up animation. And if it's negative, if it's lesser than 0, it should be like in a falling state, so the player is like falling down. Then the is charging state basically freezes the player, because in my game, when you're charging the jump, you are not able to move left or right, so it will just freeze the player animation. So over here, I set the integer, which is I want to set is the state parameter. So I set the integer of the state parameter to the integer which is associated in my enum here. So if it was to be idle, it will be 0. The integer here will be 0. If it was like falling, it will be 3. Yeah. So that's how my animation is kind of set up for the player. Okay. And now let's just play show you some of the gameplay a bit, and I'll explain the more important code or more important parts of the game as I'm playing it. So you can see I have like, I can move left and right, and then I can hold the jump button here. I'm holding jump button. You see my player is like in a charging state, and then when I let it go, he will jump up in the air. So inputting direction will make the player jump in that direction. And then based on how much you hold it, the player can, if you like don't hold it at all and just spam it, the player will just not jump very far or not jump very high at all. But if you charge it up, he'll be able to jump up. Yeah. So this is done in my player controller. Oh, oops, I forgot to on it. I forgot to open it. Player controller. Yeah, here. So this is done in my player controller. So most of my scripts are kind of like decoupled. So I actually have a player input as well. But player input is kind of straightforward. It's just getting in the input and using input dot get key down or get axis raw here, horizontal. This is for the left and right input, and using this get axis raw horizontal makes it so that pressing A or D is like left and right, and you can also press the arrow keys to go left and right. Yeah. So this is pretty straightforward, so I won't really be going through the input, but do know that most of my scripts in the player controller here are kind of decoupled out, so that they all have their own function. So first, before you can move around, you need to have a ground check to check if the player is on the ground, because I don't want my player to be moving mid-air or like jumping again mid-air. So I have a ground check, and basically I have this recast hit 2D, which is able to hold the information about a collision which is detected during a raycast or like a box cast in my case. Yeah. So this box cast is basically it just casts a 2D box at the area that I specified. So feed dot position, feed dot local scale, and 0f. So basically my player he has a box collider at his feet here. So he has a box collider at his feet here. And basically what I'm doing with this box cast is I'm setting the origin to be exactly the same at where the feet box collider is. Then I set the direction which I want the box cast to go. I set it to go downwards, since I want it to check below the feet if the player is on the ground. So it will go out by 0.3, and then it will check if it collides with my layer mask, which is, I call it here ground jump. So it will check if it collides with my layer mask, which has layer ground. So it will check if it hits the ground layer, and if it does, it will And if it does, so if it does, it will store the information into the raycast. It will store the information into the raycast. So over here, return hit dot collider is not now. So so basically that would so if a collision is detected, right, with an object, with the specified layer, so basically if it detects with my ground layer, then the method will return true, indicating that there's a object, indicating that my player object is like grounded. And if there's no collision, it means that it doesn't like detect the ground anywhere. If it doesn't detect the ground, that means that the player is like not grounded or it's not on the ground, so it will return false. Yeah, so that's how I do my ground check. Initially I had like a problem with my ground check because the player could like stand very like out of the edge, but that was because I was using a circle cast instead of a box cast, because yeah, circle cast is like a circle, so I guess when my player was like on the ledge, the radius of the circle kind of like made it so that he was still quote unquote on the ground and he like didn't fall, and I could like jump mid-air, and yeah. So after changing to box cast, everything works fine now and how I want it to. So I'll just go over like the main thing. So the main thing will just be my jumping. So is charging is basically my input. So I use the input handler to get my jump input. So this will check if the player is like holding the jump button down. So if the player is holding the jump button down, is charging is like true. So if my is charging is true and my is grounded is true, then in my like jump mechanism, which is the code which is the code that like handles all my jumping like calculations and everything. So in my play controller, so jump mechanism dot increase jump power, then I put time dot delta time. So in my jump mechanism, so it increases the jump power. So I'll take my jump power and it'll increase by the delta time. So the time to delta time is kind of like the time in between the frames. So every frame it will like increase by a bit by the amount of seconds that has passed, right? So and then I take jump power equals to the mathf dot minimum jump power max jump power. So this kind of like limits the jump power so that it doesn't go over the max jump power, because if it does, then my player can just like jump all the way up to the end without like really playing the game, right? So yeah, so that's for so this part here, input get jump input down. So when I first press the spacebar button down, it will lock the player position, so it will go into the is charging mode, and then the player can't really like move left or right. So then input dot get jump input up. So it will like when I let go of the spacebar, it will when I let go of the spacebar, it will cause my player to do the jump. So jump mechanism dot jump, and then it will make the player do the jump. So how that is done is that in my over here, it will do the jump. So it takes in the rigid body, it takes in direction multiplier is basically in which direction it's going. So no, like 1 is right and -1, +1 is right and -1 is like left. And then it takes in the movement speed, which was declared in the player controller. So basically the horizontal component, or the horizontal velocity is determined by this equation here, which is the direction times the movement speed. So if the direction is positive, it will jump to the right, and direction is negative, it will jump to the left. And the vertical component will be the jump power times the jump force. So this is declared here. So the jump power is the one that is constantly increasing, and the jump force is like a constant variable that I have. So reset jump power basically basically as the name implies, it just resets the jump power back to 0 so that the player can charge the jump again. And without this the player will like constantly be at max jump whenever they tap the spacebar. Yeah. So going back to my game, I have a unique ability called fly line. So basically it will summon the fly, and then you can either dash or swing around it. So as you can see, I can like swing, right? So I can swing around, and then I can fly, yeah. And then I can also just tap it, and then I'll like do a little like quick dash, right? So how that works is, I have in my player controller, I actually have like a little cooldown set up for each ability or each charge of the fly line. So basically what happens in this for loop, right? It will check if the charge is it has a cooldown or not. So if there is a cooldown like timing on the charge, it will basically slowly decrease the cooldown timer for each charge respectively by using the time.delta time. And until the charge is completely like no more cooldown and it's like ready to use again, it will add back the current charges so that the game will know that you have one more charge available to use. Yeah. So over here in my, I got my input handler dot get fly down input. So my fly down input down is pressing E, right? So if the current charges is more than 0, it means that there's charges like available to use. So if there's charges available to use, right? I will just take the charge index, which is max charge minus current charge. So that will be like the index for my array over here when I'm doing the cooldown timers later. So my cooldown timers, I set that index. So if let's say I have one current, I have both current charge available, right? Because my max charges is 2. So 2 minus 2, it will be 0. So it will be the first like in the array for the charge cooldown. So charge index 0, for example, and then you add the charge cooldown in. So that will have the cooldown timers 0 would have the cooldown, right? For example, and then it will start the fly line event in my event manager, and then it will set my swing check to on. So this swing check is actually since the player can't move when he is ungrounded or not grounded, the swing check allows the player to basically swing when he is doing the swing mechanic. So during the swing mechanic, when this is on, the player can like input the directions, and then there will be like added like momentum when you swing. Yeah. So when I let go of it, it will minus the current charges, and then basically it will minus the current charges, and then the timer will kind of like start ticking for the cooldown, and then it will also end the flyline event, and it will switch off this swing check so that my player will no longer be able to like move around in the air. Yeah. So let's look at the flyline code, flyline part of the code. So flyline part of the code here. So basically, to start the flyline start area. So basically this update, this basically just gets the player position, and then this calculates which direction the player is facing, so that the so that the so that you will know that if the player is facing right, it will have to put the fly line or put the fly on the right side. If it's facing left, the fly will be on the left side, right? So yeah, that's this part of the code. So now fly line start. So this line of code calculates the position of the fly uh based on like the player's position and like the fly direction, which is basically wherever the player is facing, the where the fly should be. So the fly direction would times 2, which is basically the like constant variable that is how far the fly must be, and then this is just how up the fly must be. So in the game it will just be like there, right? So that's like 2 2. So like 2 2. So yeah, that's that. And line, so basically this underscore line render visuals dot set start position, and this join visuals is a separate script which I have written. Let me open those. Line renderer and where is it? Spring join. So here you can see my line renderer. I have this I have set up some simple methods which will be used later. So I have a the start position, which will set the starting position for the line renderer, and then it will have the end position as well. And for the spring join, I also need to set the connector anchor, so like connects to where. So it will connect to like the fly, for example. It will connect to the fly, and this will let my player like swing from the fly like to the player. It will swing. The set distance and set frequency will be used whenever I switch from the dash and the swing. So if the player is still holding the button after a period of time, it will switch to the swing mechanic instead of the dash. Yeah. So now that I explained that, let's go back to my fly line. So basically, this line right, it sets the starting point for the line renderer component, and this sets the anchor to the fly position. So this both will be going to the fly position, and then I'll set the visuals. I'll set the spring join to be enabled, so that my character will have that spring tension and will start swinging, right? So I'll set the spring switch to true. So this will be used later when I am switching my spring, the distance and frequency. So now I'll instantiate the fly prefab, and I'll set it to the fly start position, and this basically makes it so that its scale and rotation is like it says it so that the scale and everything is not like messed up, and it sets the rotation so that it's not like messed up. Yeah. So I then play the audio for the fly, which you heard just now. It's like that ting sound, and then I'll invoke the spring switch. So if the player is still holding the button for like 0.25 like seconds, it will be considered as holding already, and then it will switch to the swinging distance. Yeah. So the fly swing. So the fly swing basically is just, it will keep updating the game of where the player position is, where the player position is, and then it will set the enabled to true, so you can see the line renderer, right? And since it's updating where the player position is, right, as the player position is like swinging, for example, it will look as if there's like a tongue which is like connected to the fly and is holding the frog so that he can swing left and right. fly line end basically is when a button is let go, then this will be called. So then both the spring and the spring join and the line renderer will be disabled, so that they will have no effect on the player anymore. And then I'll also destroy the fly prefab, so that the fly will just like will no longer be like on the screen. And then I'll switch the spring switch back to false, so that when I do my spring distance switch here, it will check that the spring distance is false, right? I mean, spring switch is false, right? So when the spring switch is false, it will set the distance and the frequency back to the dash distance and the dash frequency. Yeah, so that's basically how my fly line mechanic works. So another mechanic that I have in my game is that you can actually like save the game. So when you press escape, you open the like pause menu, and you can actually press save. So here it will save the game here, right? So let's say we like run over here, and then if I press load, it will load the player back to its saved position. So how do I do that? Well, I have a game handler. And I also have a save and load. Yeah, save and load. So I got a game handler here. So basically my game handler, there's a private class of player data. So basically this player data is just storing the player's position, since my game doesn't have like any abilities or like upgrades that I need to save. And the player's health is always like 1 HP, so there's no point in saving that. So I'll just be saving the player's position for now. So when this save is called, so this save is called when the button is pressed and the event is invoked. This save method will be called, and what happens is that this line will retrieve the player's position, would retrieve the current player position, and then in the player data dot position, I'll add in the player position, so that I'm like I'm storing the data of like where the player is positioned at, and then I will then I use this JSON convert.cls object player data. So basically the player data instance, which now contains the player's position, is actually gonna be serialized into a JSON string using this JSON convert.cls object method from the Newtonsoft JSON library. And this process converts the data into a format that can be easily saved to a file. Yeah. So that it can be saved to a file. And then save and load dot save JSON. So after passing through this JSON string, we'll now use the method from my save and load script. So in my save and load script, at the start there's this string save folder. This is basically just me declaring the data pathway, the data path, so that I can just easily add a save file there, add or edit the save file there. So as shown before, I'm calling the save method here. So the save method here, right? So the line uses the file.write all text, and then I have my save folder, and then I add this save.json file, and then I add in the JSON string. So this will either create or overwrite the file with the provided like name, and it'll overwrite the file with the same name, and it will overwrite it with the provided content here. So after that, you can see if it's a success and it works, it will be save success here. So after that, I press the load button. So the load button uses save and load dot load. So over here, so the load method basically responsible for reading and returning the contents. So basically this just checks if that it just checks if there's a file. Basically it checks if there's a file with the same name. Yeah, it checks if the file is the same name. If there isn't, it will just return now and like nothing will happen. So but if there is, right, if there is, this line would read the contents of the file and store it as a variable, and then I'll return it back out so that my in my game handler I can use this string. Yeah. So now back in my game handler, if the save string is not null, so if it's actually null, it will debug out that there's no save file. And if it's not null, so if it is null, it will be debugging no save file. But if it's not null, then I will deserialize that string that I read and took out from the load. So I'll deserialize it and put it into a new player data, a new instance of player data, and then I'll take the player position, which is the player object's position, and I'll set its new position to the player data dot position, so that loads the game, so that loads the player to the new position. Yeah, so that's how my save and load kind of works. Yeah. So now, moving on in my game. So you see I have a player here. I have enemy here. So that's like, so you can see the enemy is like moving left and right, and when he hits the edge here, he will like turn around. So let's see what happens if I can like kill the enemy here. See, when I jump on the enemy, he dies. Yeah, when I jump on the enemy, he dies. So I'll be going through the enemy's like mechanic now. So enemy move. So how does my enemy move? So I have a on collision exit 2D. So as you know, collision enter 2D is like when they first like make the contact. So when they first like enter, when they first like collide each other. But the exit is like it's like they exit the collision. They exit the collision. So when they exit the collision with the ground for the enemy, the transform.local scale, which is basically the enemy's game object's local scale, which is like the size and orientation of it in the game. We will make a new vector 2D. Make vector 2 and make a new vector 2, and then this math.sign rb2d.velocity.x. So basically math f.sign takes like a positive value and makes it into 1, or takes like a negative value and makes it into a negative 1. So so I added a negative in front. So let's say the velocity.x of the rigid body of the enemy is positive, means it's moving right, and then I get the sign of that. So if it's moving right, it means it's positive, so the sign of that will be the positive 1, and then I change that into negative, so that will change it into negative 1, and my local scale for my y is the same, because I'm not like flipping my thing upside down, so it will be transform.local scale.y. So if this changes the current velocity.x to like the opposite, that means that the when I do this, and basically whenever the enemy exits the collision, it will switch. It will like switch the local scale, so it will like turn around, basically. So you basically like flip the sprite. Yeah. So I also have is facing right. So basically this takes the transform.local scale. It takes the transform.local scale and it puts more than mathf dot epsilon. So epsilon. So epsilon. So basically this is like a very small like decimal. Yeah, it's a very small decimal, and I feel like it was more accurate than putting 0 because I had some errors when I put 0. So I set it to epsilon. So if the transform.local scale x is more than epsilon, it means that it means that the enemy is facing right, since it's positive, right? And if the transform.local scale is negative like 1, it means that it's less than the epsilon, and it means that the enemy is facing left. So if the enemy is facing right, it will move in a positive direction. So you move positively to the right. So it will set the movement speed to positive. But if it's moving to the left, it will set the movement speed to negative, so that it will move to the left. So how does my player kill the enemy? So how does my player kill the enemy? The enemy has so there's a kill trigger, and there's a enemy life. So with my kill trigger, it takes on collision enter 2D. So when it first collides with the so when the player first collides with the enemy, it will check if the game object that it collided with has the weakness tag. So basically you have to jump on top of the enemy, so you can't like just touch the enemy and they will die. So this basically checks if the player has jumped on top of the enemy, and if he did, it will kill the enemy. So initially I would just have like event manager dot start kill enemy, and I didn't have this parameter. So what happened without this parameter is that since all my enemies are prefabs, right? So as you can see, all my prefabs, all my enemies are prefabs. They all have the same script. They all have the same enemy life script, which in the enemy life script, it was like listening for the event to be called, and when the event was called, so when I killed one enemy, all of the enemy prefab scripts all listened to that one event, and then they all like died. They all like destroyed themselves. So to prevent that, I added a collision.gameObject.transform.parent.gameObject. So this basically gets the game object like ID, so that I can check if the game object that I am trying to kill is the same as the game object that is that like listen to the event, basically, that is that I'm trying to kill is the same as the game object that is getting killed. Yeah. So this is long because the weakness is in the enemy. Let's say this enemy, for example. The weakness is like is a child of the parent, or the parent, which is the worm. So the weakness, which is like on top, right, is the child. So to get this, because if I was just to get if I was just to get like collision.gameObject, and I check that, right, it will only check the weakness, and it only just delete the weakness. So I don't need to delete the weakness, I need to delete the entire enemy. So I had to get the parent, which is the worm, and I get the game object ID in a sense. So I get the game object, and then now in my enemy life, I take in the game object from the event. So in my event manager, my I have this public static event action game object kill enemy event. So basically my kill enemy event is not able to like take in like a parameter, and that parameter must be a game object. So I pass down the game object which is enemy, and then this basically checks if there's any subscribers to the kill enemy event. So if there's no subscribers, that means that all the enemies are dead, so there will be no point in doing this. So kill enemy event, and then I'll put in I'll pass through the enemy, and then in the enemy life, it will take the enemy and then it will check with its own game object to check if it's the same. So if the game object and the enemy that I'm trying to kill, the game object is the same, and the kill check is not true, means that this enemy has not been killed before, it will set the kill check to true, so that it will prevent the player from like jumping up and down, jumping on the weakness like multiple times to kill the enemy multiple times. And then it will make the sound, it will play the sound. It will set the enemy's animation to death, so they will be playing the death animation like you saw just now. And it will invoke the destroy enemy, so this will just basically destroy this game object. But I set it to invoke so that there is some time for the animation to play before I destroy it. Yeah, before I destroy it. So now that you've seen that, let's talk about how the player can like die. So for example, let's say I touch this spikes. You can see my player just dies and the game will restart. So that will restart. So how does that work? Is in my script, the death trigger. So basically, instead of setting, so basically it's on collision enter 2D as well. And instead of putting this trigger on the player and checking for the different types of tags, like the trap like the spikes, or like enemy like the worm, I just place the death trigger on like all my things that can kill the player, and I set it to check if the object that collides with it is the player itself. So if it is the player itself, it will then start the death event, right? And you'll set this death check to true, so that it will not like kill the player like multiple times over and over again. So now in my player life, so you see my player life listens to this event, and it will set the animation for the player to the death animation, and then it will set the rigid body type 2D to static. So basically this will make it so that the player is no longer able to move about. So basically the rigid body is now static and is unable to move, so the player can't really move left or right anymore. So I also set a new tag for the player, so that it's just a precaution to prevent the player from triggering anything after it's dead that is like connected to its like old tag, which is player. And there's also a trigger.enabled, which is like the kill trigger script in my player. I set that to false, so that if my player is like dead but it somehow connects and it hits the enemy's weakness, it shouldn't be able to kill the enemy. So by disabling this, the player will not be able to kill the enemy if it is already dead. Also invoke the restart level, which is this method over here. So this method basically gets the active scene name from my scene manager. So the get active scene is basically the current scene that is playing right now. It gets the name, and then when I load the scene by the name in this area here, so that it will load the same scene again. And then the respawn delay just makes it so that it won't immediately start the restart level, and there'll be like a slight delay before it goes to the next level. Yeah. So now I'll just show a bit of the game. Oops. So you can like this. Oops. As you can see there, the player touched the enemy there. So there's like a lot of like moves. So there's a lot. So this is actually like pretty hard. In my opinion, it's a pretty hard game. Okay. So try to jump over this, and then we'll try to like climb our way up to the top, right? So these kiwis are like just little collectibles, and you can see at the top there's like a counting timer. So okay, oh, oops, ooh. Yeah, you can see it's a pretty hard game. I'm kind of like struggling to play this game myself, but it's a lot of like cool little like it's a lot of like cool little movement techniques that you can like perform, since I'm mainly using like the physics body here. So I mean like the physics in the game, in the engine to create this game. Oh my god. No. Okay. You can see it requires a lot of precise jumping. Okay, kill the enemy there. Okay, let's get onto this platform. Then you see the way this platform is like structured, you have to like make use of the flyline ability here, so that you can get past that. So now I'm just gonna like try to skip past the enemy and go straight to the finish line. And when you touch the flag, you go to the next level. So basically, in the victory, when you collide with the flag, right, there's a on trigger enter, and then it will basically check if the tag is the player. So if it's the player and the player has not finished the game yet, it will make that like that victory sound, and it will change the check to true, so that the player won't keep triggering the victory, and then it will invoke the next level. So it will still be like a bit weird if it instantly goes to the next level, and yeah, so it will do computer level. So it will take the active scenes build index. So just now, as I explained earlier, I set the build index like in the correct order, so that it will like get the active scene dot build index, and then I can just add like 1, so that I can go to the next level. So this is like making it more like efficient for me, so that I can I am able to get the next scene pretty quick. So here you can see that there's a new enemy now, the beetle. So and now there's a new platform. So this platform actually uses the platform effector. So I made it use one way. So normally it doesn't use one way, but I made it use one way here, so that you can actually jump through the platform. So normally you can't jump through the platform here, but here in this yellow platform you can like jump from the bottom, and you can like go through it, and then you'll land on it. And this new enemy has a new way of like moving towards the player. So normally the worms are like on patrol and will move left and right, but this enemy would chase the player when it's in his radius. So how does that work? Well, over here there's the float distance equals to vector 2. So basically this calculates the distance between the enemy's position and the player's position using the vector 2 distance here. So the calculated distance would be stored in this variable here, distance. So here's a check. So it checks if the player it checks if the distance between the enemy and the player is less than the aggro distance. So the aggression distance. So if it is, then the code here will like run, but but if it is not in the aggro distance, then it wouldn't run. So this aggro distance is like the radius at which the enemy can like detect the player. Yeah. So if the enemy position, so basically this part of the code here, basically it checks for the enemy position relative to the player's position, and if the player is like a greater position, right, it means that the player is like on the right side, so the enemy should doesn't need to flip the sprite so that it can just move to the right towards the player. But I mean to the left, sorry, I mean to the left, so that it doesn't have to flip the sprite and move to the left towards the player. But then if the enemy is in a greater position than the player, it will have to flip so that it can move correctly to the player. So I'm using the vector to move towards function here to make the enemy move towards the player. So so the function takes in the current position of the enemy and the position of the player, which is like its target, and the distance to move is basically this chase speed times time dot delta time. So I use the chase speed, which is like a predetermined speed of how fast the enemy can move, and time dot delta time basically makes it so that the movement is smooth. That's one thing, and it is like frame rate independent. Yeah, so it will slowly move towards the player. Yeah, so with that, I'll just try to complete this level. So it's like jump on this guy. So yeah, that's like one of the problem with my the one way, is that sometimes when you get caught in the middle, it will just like let you just walk through. You can see when I enter the zone, it will like follow the player. See, if I come here, it will follow the player. Yeah, I can kill it as well, but it's a bit hard to kill it. There you go, kill it. So you see here, I can like jump through the platform and I'll be like fine. Okay, let's use stability here to get to the other side. Oops, jump too little power there. Okay. Oh, oops, I pressed the wrong button. Okay, so now we'll be starting from the start. Oh, I didn't jump. Yeah, so that's basically my game. Oops. So this is basically just my game. So reaching the end of the level. And with that, that's like the end of the game. So you can press either quit and this should like end the game, or you can just press main menu and you'll come back to the start again. Yeah, so that's the main points of my game. So some like critiques I have my game is that I could potentially enhance it some more by like by adding like boss fights, for example. So I know that my game I made it so that I'll just play the game as I talk. So I feel like I could add like boss fights at like the end of like maybe each level, since it's like I'm trying to like find the crow that stole my wife. Right, find the crow that stole my wife, so that so that like I have a boss fight to make the game more like interesting instead of like repetitive just climbing up the tower. Yeah. uh Another thing is that my game's movement is also a bit like uh weird to me, and I feel like I could have made my own my own like physics in the game instead of relying solely on the engine's inbuilt physics. Yeah, so thank you for listening to my video documentation.